My name is Anastasia Andrievska. I'm Competence Coordinator from ENCCS, EuroCC National Competence Center Sweden, and we help to get access for free to the best European supercomputers, and we support all stakeholders, including industry, public sector, and academia. As well, we provide proof of concept support, training materials. It's our successful use cases with industries. And for example, we have fair training materials that are also available for self-learning. And we provide access to EuroHPC joint undertaking supercomputers via different accesses, from benchmark to extreme access, which are going through EBRAINS system, Partnership for Advanced Supercomputing in Europe. And we are in Sweden co-hosted of Rice Research Institute of Sweden and Linköping University, as well as co-founded of EuroHPC joint undertaking. And what is EuroCC? EuroCC is a network of national competence centers, NCS, which are central points of contact for high-performance computing and related technologies in their countries. And there are included all European countries plus partners who have similar national center of competences, and we facilitate access to European EuroHPC joint undertaking supercomputers. Lumi and Leonardo are in pre-exascale, and soon upcoming first European exascale supercomputer, Jupiter, which is hosted in Jülich Supercomputing Center. And as part of RISE, we participate in EBRAINS to Zero project, and we are happy to shape and contribute to development of EBRAINS infrastructure. And now I will provide a user journey demo through EBRAINS website, main web page, portal, and I will go through core services of EBRAINS. The main thing of EBRAINS is infrastructure itself, which surrounded of open science tools and services. It has a lot of shared health neuroscientific data, and importantly, it has around community, which helps and shapes all these tools to coordinate and work together in order to create impact for in research, in neuroscientific and health research. And EBRAINS is a pan-European network of services that are delivered through national nodes, and there are national nodes in Sweden, Denmark, Germany, Italy, in many European countries. And as you can see, this website is pretty user-friendly and modern, and I might say nicely designed, and it was done and continuously updated by design agency Area 17, which also had developed websites for OpenAI and Balenciaga. And interesting that their Area 17, this name refers to the primary visual cortex of the brain, where senses converge to create vision. These areas was defined by German neuroanatomist Corbinian and Brodmann, who defined 52 areas in the brain, which called Brodmann areas, and this one is 17 responsible for vision. So we can start from the first and very important part of EBRAINS infrastructure is data, of course. And the central entity of EBRAINS data knowledge system is knowledge graph. And we can browse it through this link directly. It's a graphical user interface of knowledge graph, in other words, knowledge graph search. You can see there are different categories to choose, like project, dataset, model, software, as well as filters if you need to choose something particular. For example, you can use keywords to define a disease and find out relevant publications to this. As you can see, one of the top trending research datasets published on this knowledge graph was done by our Swedish colleagues from Karolinska Institute, who published MAG Parkinson dataset. And within this, you can see all relevant metadata information, how to cite, for example, this dataset, and most importantly, how to get data. There are different options dependently of how secure this data should be accessed, but one can, for example, click this button and request access with your EBRAINS account for free to get this data. And for example, if we are interested in more Parkinson's-related solutions within EBRAINS, we can, for example, Google this keyword, and we can choose model category. And here we can see multi-scale deep brain stimulation model done with the virtual brain tool. It was done by Professor Ritter's group in Charité. And if you would like to know more information about this, there are a web page to their GitHub repository, and even there are concrete information how to use this model via EBRAINS services like Knowledge Graph Query Builder or REST APIs, as well as via Knowledge Graph itself. And there are very good documentation about Knowledge Graph, which includes, for example, here we already explored this service, Knowledge Graph Search. You can launch it and get all the necessary code and learn more, because there are a lot of useful tutorials and hands-on, step-by-step how to use these tools. Besides Knowledge Graph Search, there are interesting tool Knowledge Graph Editor, which helps you to manage your metadata, as well as create and edit it through the Knowledge Graph Editor, and it has built-on ontologies. And we can launch this editor. For example, you can see there are different types of things we can look through this knowledge editor, like cell type, maybe some chemicals, data type, device types that was used to collect this data, for example. We can choose Brain Atlas as an example, and here you can see Atlas dedicated to Brodmann areas. We can choose this as well. And there are some metadata information, terminology information with digital identifier regarding this. And we can, you see, within this editor see how this information embedded to knowledge graph and how the different things related to each other. We can click more to know about these Brodmann areas. You see this, like this has free access, is related to human, it's Atlas type. And for example, we can explore group of parcellation entities, and you can see the flower of different areas, and we can even find Brodmann area 17, which we just described previously, and explore this even more. Importantly, there are metadata available in such format, as well as more information by whom it was this atlas done, where it's stored, and some terminology and atlas annotation information within this environment. Another important tool within Knowledge Graph is Query Builder, where you can create your own queries and access it from your web environment, or web browser, or use for your tools. It's user interface, which easily can help you to create such queries of data. Another tool which I like a lot is Knowledge Graph Statistics, which help us to visualize the graph and get an overview how it was changed, growing over time, as well as to navigate the structural information of a brain's knowledge graph just within our browser, and it works simultaneously. So it's interesting graphical representation of the knowledge graph with some information you can explore further, and it provides some useful information in visual way. As I told, there are a possibility to access metadata programmatically via APIs and all the code tutorials available through this documentation. And interesting two upcoming new tools like metadata, more automated tools like metadata monitoring in order to manage and monitor curation process of your data if you would like to add it to EBRAINS knowledge graph. And there are knowledge graph automations that can help you to have validation, import of information, cleanup scripts in automated way. And there are these two tools are coming soon. And another interesting solution from EBRAINS regarding data is live papers, which that serves as a complement to published scientific articles, and they have different integrated tools and services that allow users to download, visualize, simulate data, models, or results to corresponding publications. So in this way, your publications become more in alignment with open science requirements. And now I'm going to another section, core service of EBRAINS is brain atlases. And we can directly launch 3D Atlas Viewer via Zebra Explorer. And you can see there are atlases dedicated to mouse brain, for example, monkey brain. But today we are going a bit explore multi-level human atlas. And you can easily move things and find necessary places you would like to explore further. And one of my favorite tools, which I learned during PhD course in Oslo University, Digital Brain Atlases, it's called Zebra UGIX, and I will showcase it for you. We can define via this button region of interest. For example, I am interested in this part of the brain, then I can choose another ROI, this for example. I can choose some genes which I would like to explore. I will do much less permutation just for this example, some threshold, and I can directly from this atlas have a Jupyter notebook, and even I can run it. Since it takes a bit time, I've just started it already. You can run it on Binder, download it directly, and it includes all the it's generated automatically from what you choose within the Brain Atlas, and I think this is a great example of open science notebook, which is in accordance with FAIR guidelines, such as findable, accessible, interoperable, and reusable, because you can download this, share with others, and it even by default includes necessary citations. And here, as you can see, before I clicked on this button, run on lab.ebrains.eu, it's like collaboratory Jupyter Lab environment, and we can choose different high-performance computing backends. You see, Sineca, Yule, Barcelona. We can proceed with the first option. And it takes some time, and it's classical Jupyter Lab environment. We can run all the necessary cells directly here and access even more files that are shared for everyone through this collaboratory. For example, all previous events from Human Brain Project or EBRAINS available here and different interesting collabs. And yes, there are APIs also to work with data available through these atlases. Another very important core service of EBRAINS is modeling, simulation, and computing. And there are possibility to have multi-scale model of the brain with tools that works on macro scale, meso connectivity scale, and micro scale, such as Neuron, for example. And these tools are also integrated with each other. For example, as Professor Ritter showcased her use case, they successfully integrated virtual brain with the brains to simulate the effects of deep brain stimulation in Parkinson's disease. For example, about Nest, this is an interesting tool, simulator of spiking neural networks, and there are some options to use it, utilize it on high-performance computing, and even it was a successful use story that Nest was used of one of the EuroHPC joint undertaking supercomputers on Discoverer. And there are available high-performance computing via EBRAINS. It's done via Phoenix infrastructure currently, which also provide access to supercomputers via PRAISE system in the same way we do within EuroHPC joint undertaking. And available computers are Jülich Supercomputer Center, CINECA, Barcelona, and hopefully in the future EuroHPC supercomputers as well. Very important part of and unique part of EBRAINS, and the part I like a lot, it's neuromorphic computing solutions. And via EBRAINS, there are two neuromorphic computers available. One of them is BrainScales. I just had the opportunity to visit European Institute for Neuromorphic Computing in Heidelberg in Germany last week, and I saw this wonderful computer. Currently, there are BrainScales 1 and BrainScales 2 that are available via eBrains collaboratory workspace environment. So this is a specific system based on physical emulation of neuron. Which is wonderful, and one can request access via eBrains with your eBrains account directly. There are also another systems, Spinnaker, Spiken Neural Network Simulator. This is how it looks like. It's also, if you click on this button, you can, via wiki, from eBrains collaboratory, like wiki documentation, request access. It's easy, and usually quickly you can access this computer and run your first experiments. You've been allocated a collaboratory environment just for these neuromorphic experiments with pre-installed tutorials relevant for you to start with neuromorphic computing in this way via eBrains. And another very important tool and unique within eBrains is neurorobotics platform, when we can really integrate those different tools, models in to provide embodiment for robots. For those models we tested and implemented before, we can use them in neurorobotics platform. This is a platform for simulating intelligent agents within realistic environments. And this is just very smoothly being accessed through eBrains. There are different versions. I prefer this one. And I will show you how it looks like. It includes already some pre-installed, very interesting templates. You can clone this to your My Experiments folder, and from there you can launch this experiment. It usually takes some time, but depending on pressure on the system, could be pretty quickly. And it includes all the information. You can export your experiments or add files, because if you would like to if you have some advanced model of virtual brain that you would like to upload to this robot, for example, you can do this through this environment, and you even can record your experiments within this platform. And neurorobotics platform is available from Docker environment. You can upload it from your computer, but also you see it works very well from web browser. And you have brain editor, when you can of this robot you can modify a bit sensors and play around with this. I also like brain visualizer, so it's a primitive model of how this robot experiences things. You can see what spikes this brain can provide, as well as even vision of a robot to trace it, what it does. And here we can start experiment. Robot open up, doing up with with its hands and trying to catch the ball on the screen. And interestingly, we can even add other objects to the system, like another similar robot, for example. And we will have two, but in order to that robot to have something, we need to connect its own brain to the system, and all of this we can do through this environment. And as we described, there are also possibility to create your own collaboratory, your own collab with Jupyter Lab environment. We see in EBRAINS collaboratory, it's kind of workspace when you can securely share your work with your colleagues and access already almost all the tools, datasets, and resources that are publicly available, and many more for registered users via EBRAINS. Another important core service is validation and inference. After you experimented with your data and models, done some simulations, afterward you can validate these experiments and infer on high-performance computers the results, and there are different tools available. For example, FRIGHTS, Framework for Information Theoretical Analysis of Electrophysiological Data and Statistics, TVB, the virtual brain inverse, which is has very flexible causal inference at the whole brain scale in both CPU and GPUs. What I like also, there are available kind of workflows to explore virtual aging and virtual epileptic patient. You have the relevant links here. And in order to have step-by-step example of the entire workflow via Jupyter Notebooks, via collaboratories that you can directly run from a EBRAINS portal, you have different step-by-step workflows. And as it was a bit discussed previously, EBRAINS provides GDPR-compliant tools for medical and brain research, as well as very important infrastructure for TEF Health and eBrain Health research projects. For example, TEF Health, Rice Research Institute of Sweden, Karolinska, Charité are being involved in this project, and it's testing experimenting facility for health, AI, and robotics. And what I would like also to add to this part is, if you have some data you would like to share within the EBRAINS, or have partners who would like to share health data, there are possibilities to request curation, which would be done if you would like to share, because the data within the EBRAINS needed to be shared in accordance with FAIR guiding principles: findable, accessible, interoperable, and reusable. And in order to be integrated with the EBRAINS knowledge graph, you can request curation. There are also guidelines and documentation how to work exactly with this, and you even can receive a digital identificator for this, your work. Interestingly, also via EBRAINS, you have your own personal dashboard account. When you can, if you log in, you can see it's my name. We can explore my recent activity, what I checked before today, collab I am involved, maybe datasets and models I shared, some interesting noteworthy news which are available there, and as I told you, very important part of the whole EBRAINS infrastructure, it's community of researchers and people who are interested to contribute to technologies and research. It could be done via EBRAINS community. For example, you can see here is this event we are attending today, and there are different sub-communities related, and here we can see, for example, a new article about the dataset from Karolinska that I showed you was published in Nature, which is great news. There are different sub-communities dedicated for national nodes, for example, national sub-community of Denmark, Italy. There are different sub-communities dedicated to brain atlases, neurorobotics, neuromorphic computing, high-performance computing, and cloud computing, if you would like to know more. As well as we have EBRAINS on a brain sub-community with essential information about this organization and what support you can receive in your respective country, with also all the necessary news. And we have within this community subgroup for Nordic neuromorphs with biweekly journal clubs for those who are interested to know more about neuromorphic technologies. There are interesting tools like Science Market, when you can publish your ideas or startup ideas or research ideas so that people can join and collaborate further with you. And one of the interesting things we've done via community, there are also possibility to involve in research and innovation roadmaps dedicated to digital brain health, artificial intelligence, like community initiative, and it's even this report has also a digital identificator, and it's one additional research project one can be involved via EBRAINS community. So I would like to thank you again for your attention and welcome to EBRAINS community to collaborate together to shape our future health research and technological development to have better